In previous lecture, I already discussed combination with some examples. Let's see what is definition 1. Definition 1 is about combinational proof. A combinational proof of an identity is a proof that uses counting argument to prove that both sides of the identity count the same object but in different way. So it's a proof that count the argument to prove that both sides are similar. Okay, or we can say a proof that is based on showing that there is a bijection. Bijection means it's both 1 to 1 and onto between the set of objects counted by the two sides of the identity. So these two type of proof called as double counting proof or bijective proof. So a combinational proof is a proof of identity that count both side objects in different way, and if they are similar, it's a combinational proof. It can also be called as double counting proof or bijection proof. Let's go back to combinational examples. Now example 19. A group of 30 people have been trained as astronauts to go to the first mission to Mars. How many ways are there to select a crew of 6 people to go to this mission and assume all have the same job? So total there are 30 people trained, and from that we need to choose 6 people. Okay, so it will be combination of 36. So C36, it's 30 factorial divide 6 factorial multiplication 30 minus 6. 30 minus 6, that's 24 factorial. It's 30 multiplication 29 multiplication 28 multiplication 27 26 25 24 factorial divided 6 5 4 3 2 1 multiplication 24 factorial. These two will be cancelled. Now after simplification of this, we'll get 593775. So this many way we can choose 6 people from 30 people. Next example 20. Suppose there are 9 faculty members in a mathematics department and 11 in the computer science department. How many ways they are to select a committee to develop a discrete mathematics course at a school if the committee is to consist of 3 faculty members from the mathematics department and 4 from the computer science department. So in mathematics department there are 9 faculty. From 9 we need to choose 3, and in computer science there are 11 faculty. From that we need to choose 4. So it will be C93 multiplication C11 4. From 9 mathematics faculty we'll choose 3, and from 11 computer science faculty we'll choose 4. C93, that you can write as 9 factorial divided 3 factorial multiplication 9 minus 3, it's 6 factorial multiplication 11 factorial divided 4 factorial multiplication 11 minus 4, 7 factorial. Okay, so 9 factorial, that you can write as 9 multiplication 8 multiplication 7 multiplication 6 factorial divided 3 multiplication 2 multiplication 6 factorial. So this 6 factorial will be cancelled. Then this 11 factorial, you can write 11 10 9 8 into 7 factorial divided 4 into 3 into 2 into 7 factorial. So this 7 factorial will be cancelled. So we got 9 multiplied 8 multiplied 7 multiplied 11 multiplied 10 multiplied 9 multiplied 8 divided 3 multiplied 2 multiplied 4 multiplied 3 multiplied 2 multiplied 1. So after simplification we'll get 27720. There are 27,720 way to choose 3 faculty from 9 faculty mathematics department and 4 faculty from 11 computer science department faculty. Let's see next example, example 21. How many way we can select a committee of 5 person out of 5 men and 5 women so that at least 2 women included in the committee. At least 2 women means there can be 3 men. When women are 2, men can be 3. There can be 3 women and 2 men. There can be 4 women, 1 man. There can be 5 women, 0 men. Now we need to find for these individual cases and we need to add it. Okay. So from 5 we'll choose 2 women and from 5 we'll choose 3 men. So C5 2, C5 3. This is for women, this is for men. Then 3 women, 2 men, then 4 women, 1 man, then 5 women and 0 men. After solve, we'll get 226. So there are 226 ways that we can choose at least 2 women from 5 men and 5 women. C52 multiplication C53. C52 is 5 factorial divided 2 factorial multiplication 3 factorial, and C53 is 5 factorial divided 3 factorial multiplication 2 factorial. So this 5 factorial you can write as 5 multiplication 4 multiplication 3 factorial, 3 will be cancelled, divided 2 multiplication, this also you can write 5 multiplication 4 divided 3 factorial will be cancelled, so 2, 2, 2, 4 done. 5 multiplied 5, 25 multiplied 4, it's 100. So this result 100, again this result 100 as both are same. Then C54 multiplication C51, 5 factorial divided 4 factorial multiplication 5 minus 4 1 factorial. C51 also 5 factorial divided 1 factorial multiplication 5 minus 1, that is 4 factorial. 5 factorial that you can write as 5 multiplication 4 factorial divided 4 factorial. Here also 5 multiplication 4 factorial divided 4 factorial. So this 4 factorial will be cancelled. 5 multiplied 5, it's 25. So here we got 25. C55 is 5 factorial divided 5 factorial multiplication 5 minus 5, that is 0 factorial. 0 factorial is what? 1. These two will be cancelled. It's 1. C50 also same. So 1 multiplied 1, it's 1. So 100 plus 100 plus 25 plus 1, it's 226. Let's see another example. Example 22. How many binary sequence of length 9 are possible with exactly 30? It will be C93. C93 is 9 factorial divided 3 factorial multiplication 6 factorial. After simplification 84. So there are 84 binary number having 30. Next, example 23. How many binary sequence of length 10 are possible with exactly 4 0 and no 2 zeros are consecutive? So there are 6 1. Total 10, 4 0 means 6 1. So in between 6 1 there are 7 places. 1, 2, 3, 4, 5, 6, 7. In that 7 places 4 0 can be placed. So there are 7 places where we can put the 4 zeros. That's why it will be C74. C74, it's 35. 7 factorial divided 4 factorial multiplication 3 factorial. 7 factorial you can expand. It's 7 multiplied 6 multiplied 5 multiplied 4 factorial. This 4 factorial will be cancelled. Divided 3 multiplication 2 multiplication 1, 3, 2, 6 will be cancelled. 7 multiplied 5 is 35. Next, example 24. Suppose n couple are in a party. If each person shake hand with every other person except his or her spouse, then how many different handshakes are possible? So there are total n couple. N couple means there are total 2 n person. Okay. And in that 2n person, every 2 people will handshake. So it will be C2n2. And from that, n handshakes are restricted as they cannot handshake with their spouse. So C2n2 minus n. 2n factorial divided 2 factorial multiplication 2n minus 2 factorial minus n. 2n multiplied 2n minus 1 multiplied 2n minus 2 factorial divided 2 into 2n minus 2 factorial. So these two will be cancelled minus n. 2n multiplication 2n minus 1 divided 2 minus n. So this 2 will be cancelled. N multiplied 2n minus 1 minus n. So after simplification 2n square minus n minus n. So it's 2n square minus 2n. You can take 2n common. After taking 2n common, it will be 2n n minus 1. So total number of handshake possible equals to 2n multiplication n minus 1. total handshake possible equals to C2 and 2. So from that n handshakes are restricted. So C2 and 2 minus n, it's 2n multiplication n minus 1. So total 2n multiplied n minus 1 handshakes are possible if couples are not handshaking with their spouse. In next lecture, I will discuss combination with repetition. If this lecture is helpful for you, please like, share and subscribe. Thank you.